Hey, what's up, guys? So let's solve this 2492 minimum score path between two cities. Yeah, this is another question that recently weekly contest, and this problem is very simple. So you are given a positive integer n represent. So basically, you have 1 to n, which is a graph, and the roads, right? The roads is ai, bi distance. So ai are starting point and points, but this is bidirectional, and there's a distance. And you want to you define a score to be the two city minimum distance of the roads, and so you can, there's a no constraint, right? So you can, like, your goal is to from 1 to n. So in this case, you're 1 to 4, and you want to find the so-called the minimum. You need to return this minimum path. So this is simple, right? Because in this case that you can go 1 to 4. Now the minimum is 1 to 4. The minimum distance between this row is 5. And I think this problem, for this one, that you 1 to 4 is basically you can go 1 to 2. Now go back to 2 to 1 and go to the 4. So answer must be 2. Okay, so this, I think this example 2 is like very amazing, that give you the hint, give you the answer, right? Because this tell you something, right? This tell you that if you can, right? So you already know there's a path from 1 to n, right? And your answer only depends on the minimum edge. Okay, so the problem is very simple, that you first just compute the connected component of 1. Because you already know that 1 must connect to n, right? So you can compute the connected component. Now you compute a lot of these are all connected component, and you just find the minimum weight, minimum distance between the between this connected component. Okay, then you can just from 1 and go to here and pass it and pass and go back. Now your answer will be the minimum edge of this. Okay, so this must be the answer. So the very simple is that you just find a connected component of 1. So you start from 1 and find all the connected components. So basically you found this graph, you found this subplot, and compute the minimum edge. Okay, so very simple. Yeah. So let's create a graph. So I create edges, and this is basically a adjacent list. Okay, so now DFS, right? So DFS is very simple, right? So if I haven't seen the nodes, I just add it. And for each versus, if I doesn't see it, then I just DFS. Okay, so depth search, and I start from 1. Okay. So once I do this, then this thing, everything, this thing set will contains the connected component. So thing will be the connected component. Okay, so now I just iterate to the roads, and if so, I iterate roads. If the starting point or the end point are in sync, basically there must be in sync, because by definition they are bidirectional. So if they are in sync, then I just minimize the answer, right? So I initialize the answer to be infinite, and I minimize the answer to make answer smaller. Okay, and finally I return the answer. Okay, so this problem is like very simple. Once you understand trick, you just use the very depth search, and then you can easily solve this. Okay, see you guys next videos. Memory use is very small. Okay.